Good day, students. My name is Dayafa Mungonena. I am your tutor for Mathematics, Module 1. You have my contact details there. You can contact me on my mobile number or email, preferably between 2 o'clock and 8 o'clock. I would like to welcome everybody to this session. I wish you all the best in this course, as I know you are hardworking students and you will be putting in all your efforts to make sure that you succeed at the end of this course. In this presentation, we'll look at the subject content in brief, so we will not look at everything, but briefly some topics that are a bit difficult to a lot of students to understand, as I've seen in your assignments. At the end, we will look at also some pointers that you need to consider when you are preparing for your examinations. Let's look at the content. We will be looking at the topic of sequences, angle properties, factorizing quadratic trinomials, vectors, probability, as well as functions. These are considered some of the topics that quite a few of you struggle with. Let's move on to sequences. Sequences, we have two main sequences, that is the arithmetic progression, AP, and the GP, geometric progression. Students, you should be able to differentiate between these two, or when you are given a sequence, you must be able to tell, is this an AP or is this a GP? We'll have an example here. Let's say we have a sequence, half, comma, 1, comma, 3 over 2, 2, and then we have another sequence here. Let's say 7, 14, 28, 56. Right. So we want to be able to identify whether each of these sequences is AP or GP. So we have to look at the way we define this GP and AP. The AP has got a common difference and the GP has got a common ratio. So you test your sequences. Let's say the first sequence here, we test it against AP. So AP, we are looking for the common difference, which is defined by term 2 minus term 1. So we find the difference from the, let me say from the back, from the not from the previous term. Okay, we take, for example, 1 minus a half. We all know that 1 minus a half is a half. So that difference is a half. And then we look at also term, this we got a half, term 3 minus term 2. Term 3 minus term 2. That is 3 over 2, which is 1.5 minus 1. That gives us 0.5 or a half. So we can clearly see that this sequence is an AP because the difference is common. The difference is the same. So this is an AP. Looking at the second sequence, we want to test this against AP. So let's look if it's a common difference. So we take term 2, we minus term 1. So that is 14 minus 7. 14 minus 7 is 7. So that difference is 7. And looking at now term 3 minus term 2, that is 28 minus 14. That gives us 14. We can all clearly see here that there is no common difference. The difference here is 14. And the difference here is 7. So this is definitely not an AP. So let's check for GP. So GP, we are looking for the common ratio. So we look at term 3 divided by term 2, or term 2 divided by term 1, or term 4 divided by term 3, etc. So term 2 is 14 and term 1 is 7. 14 divided by 7, that is 2. This gives us 2. And term 3 divided by term 2, that is 28 divided by 14. That gives us 2 as well. So this tells us that the ratio is the same. So there is a common ratio. Therefore, this sequence here is a GP. It's a geometric progression. All right. So we should also be able to use this AP and GP to answer various questions relating to the general term formula for both AP and GP, as well as relating to the sum formula. We all know the general term formula, that is the TN formula. So that is the general term formula. Okay? So this is mostly just to talking about the terms of a sequence. And then we have the SN formula. So this is the sum formula, which is simply the sum of specific terms or sum of the terms in the sequence. Let's look at the example that is on your screen there. So we are given that the 14th term of an arithmetic sequence is negative 19. And the 9th term is negative 4. The question is to determine the 5th term. So we can now clearly see here that this is referring to the general term, the Tn, because there is nothing in this sequence that talks about the sum, or that hints us to think that we are going to use the sum formula. So we go to the general term formula for an AP. So you must remember your formula, students. So that is Tn is equals to A plus D times n minus 1. Okay, the first term, I, the common difference, and then the nth term. So we need now to substitute in all the given information so that we'll be able to determine the 5th term. So for us to be able to determine the 5th term, we need first to know what is a first term and what is a common difference. All right, so it says the 14th term of an arithmetic sequence is negative 19. So that means Tn is negative 19 and n is 14. So it says T14 actually. Right, so looking at the example that is on your screen, students, the 14th term of an arithmetic sequence is negative 19, and the 9th term is negative 4. Determine the 5th term. For us to be able to determine the 5th term, we first need to work out the value of A and the value of D. As we can all see, this specific question is referring to the Tn formula for the AP. So we write down our Tn formula for AP. So we substitute in the given values. So it says the 14th term of an arithmetic sequence is negative 19. So Tn there, which is a value of a term, is negative 19. A is the first term, we don't know, plus D, we don't know, and N is saying we have the 14th term, so N is 14 minus 1. Okay, so this is our first piece of information. So probably we can simplify it to say this is negative 19 equals to A plus D times 14 minus 1, which is 13. Simply 13D. So this is our first equation. And then we have another piece of information, which is the 9th term, which is negative 4. So there the value of Tn is negative 4, because it's saying the 9th term is negative 4. A, we don't know, plus D, and N is 9, because we are talking about the 9th term. So we have 9 minus 1. So if we simplify this, we have this, negative 4 equals to A plus 9 minus 1 is 8, so this is 8D, or D times 8, which is 8D. So this is our equation number 2. So I'm sure, students, we all know how to solve equations simultaneously. So if we look at our equation 1 and our equation 2, you can solve it them simultaneously using elimination or substitution. And from there, you will find that the value of A is 20, and the value of D is negative 3. So now that you have the value of A and the value of D, you'll be able to find the 5th term. Okay, because that was a question, determine the 5th term, the value of a 5th term. So the value of a 5th term, you now look at the general formula. A is 20, as you have worked out, plus D, the common difference, that is negative 3, times N minus 1. Okay, and in this case, N is actually 5. Okay, so this is 5. So you use your calculator to work it out. So that is 20, and that is minus 3 times 5 minus 1 is 4. So you have 20 minus 12, which is 8. Therefore, our 5th term is simply 8. So let us now move on to the next one, which is angle properties. We are moving on to angle properties. So students, you need to know your angle properties, specifically circle geometry. This we are talking about angle in a semicircle. Okay, angle in a semicircle is angle in a semicircle is 90. The angle between a tangent and the radius is also 90 degrees. The angle at the center is twice the angle on the circumference. Angles in the same segment are equal, and also angles in opposite segments are supplementary. Let's look at this question now. We have an example here. A circle with center O has chords BC, BC is a chord, and AD is also a chord, which are extended to meet at point E. So the chords BC or BC is extended to meet chord AD at point E. Right. The first question is, probably you can look at this bigger picture if you can't see what is on your screen. On the slides, you can look at this one. So, the first question A is, we need to give a reason why angle CAD is 25. Why angle CAD is 25. Where is angle CAD? CAD. We are talking about this angle here. Why is this angle 25? The reason is this angle CAD is in the same segment as angle CBD. We can all see that angle CBD is subtended by this arc. Okay? And if we look at angle CAD is also subtended by that same arc. Therefore, these two angles, angle CAD and angle CBD, are in the same segment, and we all know that angles in the same segment are equal. The next question, B, find the size of angle BCD, giving a reason for your answer. Angle BCD. Angle BCD. Angle BCD, we are talking about this angle here. Okay, we want to find the value of this angle, and we give a reason, or we show our calculation there. So, angle BCD, how are we going to calculate this angle? So, we know that angles in opposite segments are equal. So this angle already here, we worked out that this angle is 25. Okay, so that means this whole angle here is 65. Okay, so this angle BAD is opposite angle BCD. These two angles, this angle and this whole angle, are angles in opposite segments. Therefore, they should be supplementary, meaning they should add up to 180. Therefore, for us now to work out this angle, we'll simply subtract this angle, which is 65, from 180. And that is how we get 115. 180 minus 65. That is how we find the value of angle BCD, which is 115 degrees. And the reason is these are angles in opposite segments. Let's move on to the next question, which is to find the size of angle BDA. Angle BDA. BDA. We are talking about this angle here. Okay, we are talking about this angle here. So, first of all, you need to look at this. This point here, O. O is the sender. We were told at the beginning that O is the sender. So, what we are saying here is this whole angle here is 90 degrees. Why is this whole angle 90 degrees? Because this is the angle in a semicircle. This is the angle in a semicircle. Because we can all see this angle is opposite the diameter. Is opposite the diameter. Is subtended by the diameter. So, how do we determine this angle then? Angle BDA. Angle BDA. We want to find this angle. But we know this whole angle is 90. And the other thing as well, we have angle AD We have angle. Actually, here we have angle. This angle here. This angle right here. This angle is 40 degrees. This angle is 40 degrees because if we look at this angle and this angle, they are angles in the same segment. So you can see this angle here is closed up by the chord BC. And angle BAC is also subtended by the same chord. Therefore, these two angles, angle 40 and angle CDA, are angles in the same segment. So this angle is 40 degrees. Therefore, our angle that is asked there, that is angle BDA, will take 90 degrees minus 40 degrees. And that gives us 50 degrees. So our angle BDA is simply 50 degrees. So that angle is 50 degrees. All right. The next question, we want to find the size of angle BED. Where is angle BED? BED is this angle here. We want to find the value of this angle BED. So before we find angle BED, I want us to look at angle BDE. 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 This angle here. My paper is messed up here, but I hope you can see. This angle is on a straight line with this angle. Therefore, this angle is simply 180 minus this angle, which we said is 50 degrees. Okay? So, our angle, let me write it somewhere here. Our angle BDE is 180 minus 50. So this angle here is 180 minus this angle 50. So that will give us 130 degrees. So this angle is 130 degrees. So if we look at now triangle BDE, we know two of the angles of that triangle, which is this angle 130 degrees and then the angle 25. So now for us to work out this angle in this triangle, we need to subtract this angle 130 and angle 25 from 180. So our angle BED finally is 180 minus the angle 130 minus the angle 25. And that gives us 25 degrees. So that is how we work out this angle BED. All right, so that's all we had on angle properties. We are moving on to factorizing quadratic trinomials. Factorizing quadratic trinomials. So I want us to look at the first question here. We are trying to factorize x squared minus 7x plus 12. So actually there are two ways that you can use to factorize quadratic trinomial, and this is mostly dependent on the coefficient of a squared term. If a coefficient of a squared term, for example in this case, if that coefficient is 1, there is no number there in front of x squared, that means the coefficient is 1. What we do, we will simply look for any two factors of 12 that will multiply. When you multiply those two factors, they will give you positive 12, and when you add them, they will give you the coefficient of the middle term, which is negative 7. So now we need to consider those the signs of those factors. Are they all going to be positive? Are they all going to be negative? Or are they going to be a positive and a negative? As you can all guess here, these two factors of ours, they are all going to be negative. Because for you to multiply and get the last term, it could either be a positive times positive, so you can get a positive 12. But then, a positive plus a positive will never give you a negative, which is a middle term. So this should be all factors of 12 that are negative. So which two factors of 12 will add up to give you negative 7? We can all guess that is negative 3 and negative 4. Therefore, this will factorize into x minus 3 times x minus 4. Okay? And you can always check to see if you have factorized correctly. This is negative 3 and this is negative 4. If you add these two together, you get negative 7, which is the coefficient of your middle term. Alright, let's now look at the second question, which is 3k squared minus k minus 4. Okay, this one is a little bit different in the sense that the coefficient of a squared term is not 1. The coefficient of a squared term is not 1. So what we do in this case, we'll look at the factors of the coefficient of the first term. Okay, the factors of 3. The factors of 3, we have 1 and 3. Those are the only factors of 3. And then we should also look at the factors of the last term, the constant, which is 4. So that is 1, 2, and 4. So what we will do from there, we would want to rewrite each of these factors backwards. So the factors of 3, say this is 3 now, and this is 1. Factors of 4, backward, that is 4, 2, and 1. Right. So now what we would want to do now here is take one pair of factors from each of these sides of factors. So we'll take this one, that is 1, 3, and then this one. But before we do that, students, we need to identify the signs of these factors. So we need to know, are these factors of 4? Actually, we do not worry about the signs for the factors of the first number or the coefficient of the first term. You worry about the signs of the factors of the last term. So looking at the last term here, the last term is negative. And remember, we get this last term by multiplying the factors. And we know it is only a negative times a positive that will give us a negative. Therefore, one set of these factors is going to be positive and the other one is going to be negative. Right. So let's say I choose these ones to be negative and the last one here at the bottom to be positive. So what we would want to do is we want to take one pair here and one pair there, and then we cross multiply. You cross multiply and add and see which combination will give you the coefficient of a middle term. The coefficient of a middle term here is 1. Okay, is 1. Specifically, negative 1. So let's cross multiply and see what is the result that we will get. So this is 1 times 4, and this is 3 times negative 1. This is positive 4 plus negative 3. That is positive 1. Therefore, this is not the right combination that we need. So we move on. Let's try now this combination of 1, 3 and negative 2, 2. So we'll have here positive 1 times 2 plus 3 times negative 2. So that is positive 2 plus negative 6. That will give us negative 4. We are not looking for negative 4. We are looking for the answer that the combination that will give us negative 1. So we move on to the next combination. Let's now try 1, 3 and negative 4 and 1. So cross multiply, that is 1 times 1 plus 3 times negative 4. So that is positive 1 plus negative 12. So that is negative 11. We do not want negative 11. Right, so we will now go to this combination. We try it with each and every other combination here. So we are now looking at this with each of the factor combinations of 4 on this side. Right, so let's look at the first one here. 3 times 4, that is 12, plus negative 1, that is positive 11. We do not want positive 11. Right, then we try it with this combination here. So that is 6 times negative 2. 3 times 2, which is 6, plus 1 times negative 2. So that is 6 minus 2. 6 minus 2 is 4. We are not looking for 4. We are looking for negative 1. So we try this combination with this one. So what we will have here is now 3 times 2 is 6 plus 1 times negative 2. So that is 6 minus 2. That is 4. Actually, this is what we have tried already. Let's try the last one. So that is 3 times 1 plus 1 times 4. This combination here. Okay, so 3 times 1, that is 3, plus 1 times negative 4, that is negative 4, and the answer is negative 1. So this is a combination that we are looking for. Okay, so the combination that we got is 3, 1, and then negative 4 and 1. So these are the factors of 3, which is the first term. So we are going to add a k here and a k there. And then this will give us our first bracket, and this will give us the second bracket. So we can all see that our first bracket is 3k minus 4. And then our second bracket will be k plus 1, because this is positive 1. So that is how we got the answer that we have on our screen there. So probably we can do one more example here, especially when we have the last term here, probably is positive. Let me give you the third example. See, let me say we have 2x squared minus 7x plus 3. We want to factorize this. So once again here, we are going to look at the factors of the factors of 2, the coefficient of the first term. So that is 1 and 2. Backward, that is 2 and 1. And then we look at the factors of the last term. So the factors of 3. So that is 1 and 3. Backward, 3, 1. So now, looking at the last term is positive. Okay? So Do we need the two factors? Do we need the two factors, both positive, both negative, or positive and negative? We can all see in this case it's a positive. Let's check if it's a positive and a positive. Positive and a positive will multiply to get a positive, but positive and a positive will never add together to give us a negative. And then we have a negative times a negative. A negative times a negative will also give us a positive. And we all know a negative plus a negative will give us a negative. Therefore, these two factors of ours, they are all going to be negative. So what we are going to do is, looking only at the pairs of the factors of 3, the last term, we make all of them negative. All of them negative. And then now we start to look for our combination that when we cross multiply and add, we get negative 7. So let's try these two. Okay? If you cross multiply here, so this is negative 3 and this is negative 2. Negative 3 plus negative 2 is negative 5. We are looking for negative 7. So this doesn't work. So we move on to the other one. Okay, so this doesn't work. So now we are trying out this combination and this combination. Okay, so that is 1 times negative 1. So this is negative 1 and this is negative 6. Okay, if you cross multiply here, so that is negative 1 and this is negative 6. You add negative 6 and negative 1, you get negative 7. Therefore, this is a right combination. This is a right combination. So what we will do, we'll just add an x here and an x here, and then we'll have this as our first bracket and this is our second bracket. So we can all see that our first bracket is x or 1x minus 3, and then the second bracket is 2x minus 1. So we write it out here. So x minus 3, you don't need to write 1x, and this is 2x minus 1. So we have done factorizing this quadratic trinomial. Now let's move on to the next part, which is vectors. Okay, so you need to be able to do vector geometry. For example, multiply vectors, add vectors, and also find the magnitude of vectors. So the example that we have here, we are given vector P, vector Q, and vector R. So you need to work out, for example, 2P minus Q. When you are multiplying vectors, that is now 2 times vector P. So each component of a vector you multiply by 2. So 2 times 3 will give you 6. And 2 times negative 5 will give you 10. So that is 2P. So you minus vector Q. Subtracting the vectors, you subtract them component by component. The top component minus the top component. 6 minus 4 is 2. And also the bottom components, negative 10 minus 4, that is negative 14. For the magnitude, you need to remember the formula, which is the square root of the x component squared plus the y component squared. And this is what happened here for us to find the magnitude of vector R. Right, let's go to the next part, which is probability. So we are given that a basket contains 3 orange fruits and 2 lemon fruits. Tom selects 3 fruits with replacements. So when you are doing probability, especially when your aim is to draw a tree diagram, you must be able to check nicely, is it with replacement or without replacement? Alright, so since here we have 3 orange fruits and 2 orange fruits, that means the total fruits we have are 5. Therefore, our denominator is going to be 5. And then for the oranges, we have 3 out of 5. And for the lemons, we have 2 out of 5. So each and every time, you have 3 out of 5 for the oranges and 2 out of 5 for the lemons, because there is no replacement. So to answer these questions quickly here, to find the probability of selecting at least 1 orange fruit. So the probability here, if we look at the tree diagram, at least 1 orange fruit, we mean that there must be at least an O there. And the only root without O is the last one here. So 2 out of 5 times 2 out of 5 times 2 out of 5. So to find the probability of selecting at least 1 orange fruit, we would take the probability, the total probability, which is 1, and we minus the probability of selecting all lemon fruits, which is calculated here. So students, I would like you to go through all the slides here as we now conclude this because of time. So go through the functions and the few pointers. So students, when you are answering your questions in the examinations, please make sure that you go through the questions. You answer the questions that you know very well, and make sure at least you don't leave questions unanswered, because you also get marks for the methods, even if in the end your answer is probably wrong. So I wish you all the best, students, in your upcoming examinations. Good luck.